Friends, in this lecture, we shall discuss Prestressed Concrete. The objectives of this lecture are to understand the concept of Prestressed Concrete, to study different prestressed elements, to demonstrate the process of pre-tensioning and post-tensioning. So what is Prestressed Concrete? Concrete in which reinforced steel bars are staged and anchored to compress it and thus increases its resistance to stress. So normal RCC reinforced cement concrete, it is weak in compression and good in tension. Right? So intention of this prestressed concrete is to increase the compressive strength. So prestressing is a method in which compression force is applied to the reinforced concrete section. The effect of prestressing is to reduce the tensile stress in the section to the point till the tensile stress is below the cracking stress, and in turn you can say to increase the compressive strength. Thus the concrete does not crack. So prestressing means the concrete in which reinforcing steel bars are staged and anchored to compress it and thus increase its resistance to stress. To increase the tensile, to increase the compressive stresses, prestressing is done in the concrete. Prestressed concrete methods. So mainly there are two methods. Pre-tensioning, most often used in factory situations. Post-tensioning, it is used at the site. So what is pre-tensioning? In pre-tensioning, the tendons, these are the cables or you can say wires, are tensioned against some abutments before the concrete is placed. After the concrete hardens, the tension force is released. The tendon tries to shrink back to the initial length, but the concrete resists it through the bond between them. Thus, compression force is induced in concrete. Pre-tension is usually done with precast. So, in case of pre-tensioning, the tendons or the wires, these are tension against some abutments before the concrete is placed. Before placing of the concrete, the tendons, these are stretched and then concreting done. After the concrete hardens, the tension force is released. When concrete hardens, it achieves certain strength. The tension force is released. The tendons tries to shrink back. In that case, the tendons or those wires will try to shrink back to the initial length, but the concrete resists it. As concrete hardens, it will resist it through the bond between them. Thus, compression force is induced in concrete. Pre-tension is usually done with precast, so it helps to increase the compression strength because RCC is weak in compression and is good in tension. So here you can see the process of pre-tensioning. So in case of pre-tensioning, first the jacks are arranged depending upon the length of beam. Then tendons or these wires, these are fixed to the jack, and then proper tension is given to these tendons, and then concreting is done. After hardening of the concrete, the tendons are cut, and in that case these tendons, this will try to induce a compressive force in the concrete, and in turn you can say compressive strength will get increased. Here you can see the flow chart of pre-tensioning process. First, anchoring of the tendons against the end abutments, placing of the jacks, applying tension to the tendons, casting of concrete, and then cutting of the tendon. Same thing is shown in the help of sketch here. Now coming to post-tensioning. In the post-tension, the tendons are tensioned after the concrete has hardened. Commonly, metal or plastic ducts are placed inside the concrete before casting. After the concrete hardened and hard enough strength, the tendon which was placed inside the duct stressed and anchored against concrete. Grout may be injected into the duct later. This can be done either as pre-cast or cast in situ. So in case of pre-tensioning, the tendons are tensioned before casting of the concrete. In post-tensioning, the tendons are tensioned after the concrete has hardened. First concreting is done, and when it hardens, after it post-tensioning is done. Commonly metal or plastic duct. For this purpose, metal or plastic duct is placed inside the concrete before casting, so that there will find space for positioning of the wires, or you can say tendons. After the concrete hardened and had enough strength, the tendon which was placed inside the duct stress. After hardening of the concrete, the tendons are stressed and anchored against concrete. Grout may be injected into the duct later. After giving tension to the tendons, grouting of the concrete or grouting is done, grout is injected into that duct. This can be done either as precast or cast in place. So this is regarding post tensioning pressure. So here you can see this is the tendon or wire, this is the beam section, concreting is done, and then here duct is provided. Through this duct this wire is provided, and then here you can say this is the vent is provided, this is the grout tube, here grout tube is provided, stressing anchorage is there, dead end anchorage, this is the dead end, and this is the grout tube. From both the ends grouting is possible in case of this post tensioning applications. So these pre-stress elements are used for bridges, slabs in buildings, water tank, concrete pile, thin cell structures, offshore platform, nuclear power plant, repair and rehabilitation structure. Now coming to advantages of this pre-stressed concrete. Take full advantage of high strength concrete and high strength steel. Need less materials. Smaller and lighter structures are possible. No cracks will be there. Use the entire section to resist the load. Better corrosion resistance. Good for water tanks and nuclear plant. Very effective for deflection control. Better shear resistance. So these are the advantages, very advantages with compared to conventional concrete. Coming to disadvantages, need higher quality material. This requires higher quality material, more complex technically. Technically it is complex, it is difficult, more expensive, it is expensive, and harder to recycle. When it is required to recycle, in that case it is very difficult. So this is about pre-test